Hello everyone, welcome to this lecture video of operating system deadlock. In the previous lecture video we discussed what is deadlock and what are the characteristics of deadlock, how deadlock occurs in the operating system. In this lecture video we are going to discuss the examples of how the resource allocation happens in the set of in this example we can able to see in the picture we have the resources R1, R2, R3 and a process as P1, P2, P3. So the set of process and resources and final graph E equal to P equal to P1, P2, P3 and R equal to R1, R2 up to R3. So final execution equal to the graph we have P1 will allocate the resource of R1, P2 will allocate the resource of R3 and and the R1 will allocate have the resource allocated to the P2 and R3 allocated to the P3. For example, here the R2 allocated to the P2. For R2 is here allocated to the P2 and R2 allocated to the resource will be a process 1 and R3 allocated the process to the P3. So here the resource instance is one instance of resource type R1, two instances of resource type R2. R1 have only one instance of R1. The two instances of resource type is R2. There are only one resources you have in the resource 1. R2 have two instances of resources. It will allocate the one instance will be to the process 1 and another instance will to the process 2. Then one instance of resource type is R3. R3 have only one instance of resource type. Similarly like that R1. Three instances of resource type R4 is there are three dots. We have in the picture we can able to see. So process state we have process P1 is holding an instance of resource type and R2 is waiting for instance of resource type R1. So process P2 is holding instance of R1 and instance of R2 and is waiting for an instance of R3. So process P3 is holding instance of R3. So for example here the process P1 is holding instance of resource type R2 and waiting for instance of resource type R1. So process P2 is holding instance of R1 and instance of R2 and is waiting for instance of R3. So process P3 is holding instance of R3. So here the resource allocation graph with a deadlock R1, P1, P2, P3. For example, P1 have the resource allocation graph with a deadlock. P1 will be have the resource of R1. The same R1 will have the resource of P2, and also the P2 will be having requesting the resource of R3, but R3 is allocated to the P3. So in the R2, the same instant two instance of resources will be claiming the P1 and P2. So here graph with cycle but no deadlock. A graph with cycle with no deadlock. In the previous graph we have some deadlock. Why? Because of same resource will be allocated for P1 and also requesting for other process. So here P1 will be allocated with the resource of things. We have the P1 will be allocated to the resource R1 and R1 will be allocated to the P2. R1 will have the resource of P3 and R2 will have the request will be request to the process 1. So here the graph with a cycle but no deadlock. So in this graph we can able to see there is no each process have some other allocated with some other resources, and also there is no same resource will be allocated or requested for the other process. So it is a graph with a cycle but no deadlock happens here. So basis fact of deadlock is if graph contains no cycles, there is no deadlock. If graph contains a cycle, it will be a causes of deadlock. If only one instance per resource type, then deadlock will be happen. There is a no cycle, it will be no deadlock. If several instances per resource type, possibility of deadlock will be happens. So methods of handling deadlock ensure that the system will never enter a deadlock state. Deadlock prevention and deadlock avoidance will be major things to avoid for handling these deadlocks. Allow the system to enter a deadlock state and then recover. So ignore the problem and pretend the deadlocks never occur in the system. Used by the most operating system including the Unix. So here we only deal with the deadlock problem in the three ways. We can allow the system to enter deadlock state, detect it and recover. We can ignore the problem altogether and pretend the deadlocks never occur in the system. So deadlock prevention can be happens At least one of these conditions can hold. We can prevent the occurrence of deadlock. Mutual exclusion, hold and wait is the first thing. Mutual exclusion, not example read-only files, not required for shareable resources. It's only a read-only file, must hold for non-shareable resources. So hold and wait is must guarantee that whenever a process requests a resource, it does not hold any other process. So require process to request and be allocated all its resources before it execution, or allow the process to request the resources only when the process has none allocated to it. Low resource utilization and starvation possible. So deadlock prevention, no permission, circular wait also having. So in this circular wait, we have the different kinds of things we are going to discuss that deadlock prevention. Thanks for watching. We can see in the deadlock examples and other things in the next video. Thank you.